Okay, 12.7, special products of binomials. Here we're going to be multiplying binomials, finding products that are the difference of two squares, and square binomials, finding products that are perfect square trinomials. Okay, difference of two squares. The definition of a difference of two squares is whenever you have something of x plus a and a parenthesis of x minus a, that also comes into the form of x squared minus a squared. Okay, let's look at an example of one of these and I'll show you what I mean. Notice we have x plus 4 and x minus 4. We could start foiling this out, but if we remember that if we have something of that form, which is, okay, if we have x plus a and then also x minus a, it's also of the form of x squared minus a squared, which means we can come in here and go, well, if I've got this x squared here, notice I've got this x part, and then this right here is going to be my a. Well, then we can write this in the form of, okay, well, what's x squared minus, and then we've got this 4, so I've got to have this 4 squared. Well, when we finish that, we're going to get x squared minus 16. Okay, and that is what the difference of two squares would look like, because if you decide to FOIL all this out, you would end up getting this right here, which we can come in here and look at and go, okay, well, if I go ahead and FOIL this guy here and I FOIL him here, well, notice I'm going to have x squared minus 4x, and then right here I'm going to have this plus 4x, and then I have plus 4, okay, well, that's going to be a positive 4 minus multiplied by a negative 4, and that's going to give me negative 16. These guys in the middle cancel out, and that just gives me the x squared minus 16. So notice they equal out. That's why this process works. So, and I say that just to let you know, if sometimes you may not see this, maybe you're just not trained to see it yet. If you don't, you can FOIL and you'll still get the exact same thing. Okay, let's continue on and let's look at a square of binomials, or a perfect square trinomial. So if you have something of x plus a squared, you can put it into this formula right here and it will work out and give you the exact same thing. So let's do an example here. We have 2x plus 3 squared. Okay, well, let's go ahead and put this into our formula. It says, let's look back up at it, I can put it into this form right here, and I'll get the square of a binomial sum. Let's come over here. I'm going to come here to the top here and write out our formula that we're going to be using. We're going to be using x plus a squared, which is going to equal out to x squared plus 2ax plus a squared. Now we just need to make sure to go ahead and identify everything that's going to be in here. Okay, well, notice you've got this right here. So this is going to be your x, okay, and this is going to be your a. Okay, so let's go and start putting everything here. Notice we've got this x squared here, so this is all going to equal 2x. Let's go and put it in our formula. And then we're going to have a plus, and I have a 2. Well, notice my a is going to be my 3, and then my x is going to be my 2x. And then I have this a squared, which is going to be my plus 3 squared. Well, I can go and start simplifying this. I'm going to go ahead and distribute that power of 2, which is going to give me the 4x squared. Okay, notice here I have 3 times 2, which is going to give me a 6x, times 2 is going to give me a positive 12x, and then here I'm just going to have the 3 squared, which is going to be 9. And so that's how you could work this one out very quickly. Or what you'll sometimes see done is this. You could have also FOILed this out. You could have done 2x plus 3 and then 2x plus 3, and then you could have come in here and you could have FOILed that and you would have still got the same answer there. Okay? Just one little common error that you're going to see people make, though, is many algebra students make the following error. Notice what they do. They take this square and then they just jump it inside here. You can't do that. Okay? Avoid this error by remembering that the square of a binomial is a trinomial. Okay? Because look, you were prevented from distributing this power of 2 in there because of this operator of a plus or a minus. So you can't do that. So